Helping learn, inspiring minds, building futures. Empowering developers with essential Java programming insights. Navigating the Java landscape. This presentation will guide you through the fundamental building blocks of Java programming, from basic data types to advanced concepts like big integer and variable modifiers. Let's unlock the power of Java together. Data types and variables. 1. Operators and control flow. 2. Advanced data handling. 3. Variable modifiers. 4. Key differences and conclusion. 5. Java's foundation. Data types. Java is a strongly typed language, which means every variable must have a declared data type. Understanding these types is crucial for efficient and error-free coding. Data type. Size. Example values. Default value byte. 1 byte, -128 to 127. 0. Short. 2 bytes, -32,768 to 32,767. 0. Int. 4 bytes, -2 to the power of 31 to 2 to the power of 31 minus 1. 0. Long. 8 bytes, very large whole numbers. 0L. Float. 4 bytes, 3.4e-038 to 3.4e plus 038. 0.0f. Double. 8 bytes, 1.7e-308 to 1.7e plus 308. 0.0d. Char. 2 bytes, single Unicode character, U0000, Boolean. 1 bit, true or false. Variables. Storing data in Java. Variables are containers for storing data values. In Java, there are 3 main types, each with a distinct scope and purpose. Local variables. Instance variables. Declared inside methods or blocks. Their scope is limited to the block they are defined in, making them temporary storage during method execution. Unique to each object and declared inside a class but outside any method. They define the state of an object. Int instance var equals 5. Int local var equals 2, static variables. Shared by all instances of a class. Declared with the static keyword, they belong to the class itself, not to any specific object. Static int static var equals 10. Operators and control structures. Operators allow you to perform operations on variables and values, while control structures manage the flow of your program based on conditions. Operators. Control structures. Arithmetic. Plus, asterisk, %. Conditional statements. Relational. Equals, less than, greater than equals, if else blocks execute code based on specific conditions, providing branching logic. Logical. An assignment. Equals, plus equals, asterisk equals. Increment, decrement, plus. Switch statement. A multi-way branch statement that provides an easy way to dispatch execution to different parts of code based on the value of an expression. Loops for while, do while, and for each loops enable repetitive execution of code blocks, crucial for iteration and automation. Handling large numbers with big integer. When long isn't enough, Java's big integer class comes to the rescue, allowing you to store and operate on integers of arbitrary precision. The Java math big integer class provides methods for arithmetic operations such as addition, subtraction, multiplication, division, and modulo, making it ideal for cryptographic calculations, scientific applications, and financial modeling where precision is paramount. Important note: big integer objects are immutable. This means that once a big integer object is created, its value cannot be changed. Any arithmetic operation on big integer will result in a new big integer object. Import Java math big integer big 1 equals new big integer 123. Big integer big 2 equals new big integer 987. Big integer result equals big 1.add big 2 system.out println result. Understanding static and final. These keywords are powerful modifiers in Java, influencing how variables behave and are initialized. Static variables, final variables, belong to the class, not individual objects. They are shared across all instances, making them ideal for common counters or utility fields. Once initialized, their value cannot be changed. They act as constants, ensuring data integrity. Final int max _users equals 100, static int count equals 0. Key differences at a glance. Understanding the distinctions between similar Java constructs is vital for effective programming. Primitive versus non-primitive. Loops. For versus while versus do while. Primitive. Non-primitive. For loop while loop do while loop. Built-in. Created using classes. Inside loop header. Outside loop. Outside loop. Fixed memory size. Variable size. Before execution. Before execution. After execution. Example. Int. Example. String. Array. Big integer. Known iteration. Unknown iteration. At least once needed. Key differences at a glance. Understanding the distinctions between similar Java constructs is vital for effective programming. Primitive versus non-primitive. Loops. For versus while versus do while. Primitive. Non-primitive. For loop while loop do while loop. Built-in. Created using classes. Inside loop header. Outside loop. Outside loop. Fixed memory size. Variable size. Before execution. Before execution. After execution. Example. Int. Example. String. Array. Big integer. Known iteration. Unknown iteration. At least once needed.